For generations, humanity has looked up at the night sky and asked one profound question. Are we truly alone in the universe? The stars above, countless and shimmering, have always stirred our imagination. Ancient civilizations crafted myths from constellations, early scientists theorized about other worlds, and in modern times, space agencies have launched powerful telescopes into orbit, searching for signs of something, or someone, out there. For centuries, the idea of extraterrestrial life has existed at the boundary between hope and theory, but today, that boundary has shifted. What was once a tantalizing mystery has now become a transformative reality. In a stunning announcement that echoed across the scientific world, NASA's director confirmed an extraordinary discovery captured by the James Webb Space Telescope, humanity's most advanced and ambitious tool for exploring the universe. The telescope recorded unmistakable signs of biological activity on the exoplanet Proxima B. This revelation marks a turning point in our search for life beyond Earth. For the first time, we may have direct evidence that we are not alone. That life exists beyond our solar system. That somewhere out there, under a different sun, nature found another way to thrive. This is not science fiction. This is science at its most profound. To understand how this discovery came to be, we must begin with the James Webb Space Telescope, a masterpiece of modern engineering and perhaps humanity's most powerful window into the cosmos. Launched in late 2021 and fully operational by the middle of 2022, Webb was designed to see deeper into space and further back in time than any instrument before it. Unlike the Hubble Space Telescope, which observes primarily in visible and ultraviolet light, Webb specializes in the infrared spectrum. This is essential because infrared light can pass through dense clouds of gas and dust, the kind that often blocks visible light, giving astronomers access to hidden corners of the universe that were previously beyond our reach. At the heart of Webb's revolutionary design is its massive primary mirror, measuring 6.5 meters across. This mirror, made of gold-coated beryllium and composed of 18 hexagonal segments, is more than twice the size of Hubble's. It collects over 6 times more light, allowing Webb to detect faint glimmers from the edge of the observable universe. The telescope operates from a carefully chosen location, nearly 1.5 million kilometers from Earth, at the second Lagrange point. This unique position allows it to remain stable while avoiding interference from the Earth and Moon, enabling long-duration observations with stunning clarity. But the mirror is only part of what makes Webb so powerful. The telescope is equipped with a suite of advanced instruments designed to analyze the universe in ways never before possible. These instruments include the near-infrared camera, which captures high-resolution images in near-infrared light, revealing young stars, galaxies, and planetary systems. The near-infrared spectrograph breaks light into its component wavelengths, allowing scientists to study the temperature, movement, and chemical composition of stars and exoplanets. The mid-infrared instrument, or MIRI, specializes in detecting heat signatures and analyzing atmospheres. These instruments, working together, give Webb the ability to detect what we call biosignatures, the chemical fingerprints of life. This brings us to Proxima B, the planet at the center of this discovery. Located just over 4.2 light-years away, Proxima B orbits Proxima Centauri, a red dwarf star and the closest known star to our solar system. Though invisible to the naked eye, Proxima Centauri has long fascinated astronomers due to its proximity. Discovered in 2016, Proxima B was identified as an Earth-sized planet located within the star's habitable zone, the region where temperatures might allow liquid water to exist. This immediately placed it on the short list of promising exoplanets for further study. However, red dwarf stars like Proxima Centauri are volatile and prone to intense stellar flares, which can strip away planetary atmospheres and complicate the search for life. Scientists were skeptical that such a planet could retain the conditions necessary for biology. But with the James Webb Space Telescope, we finally had a tool capable of looking past the challenges and into the very makeup of Proxima B's atmosphere. Using a method known as transit spectroscopy, Webb observed Proxima B as it passed in front of its star. During these transits, some of the star's light filters through the planet's atmosphere. This light carries subtle changes caused by the gases present in the atmosphere. By analyzing the changes in the light spectrum, Webb was able to determine what elements and molecules exist in that thin shell of gas surrounding the planet. What the telescope found shocked even the most cautious scientists. Webb detected a complex mixture of gases that are extremely difficult to explain through purely geological or chemical means. Methane and carbon dioxide were present in unusual ratios, along with water vapor. Even more intriguing were potential signs of nitrous oxide, a compound rarely found outside biological contexts. Most surprising of all was a faint but consistent signal of oxygen, one of the clearest indicators of life as we know it. These findings suggest a planet with an active atmosphere, possibly supported by biological processes. While this doesn't mean intelligent life or even visible organisms, it strongly indicates that microbial life, or something similar, could be flourishing on Proxima B. These organisms may resemble Earth's extremophiles, microbes that thrive in the deepest oceans, volcanic vents, or frozen tundras, capable of surviving harsh conditions and producing detectable gases as byproducts of their metabolism. This discovery transforms more than just science, it changes perspective. For centuries we believed Earth might be the only cradle of life. Now we know there is another. And if life can arise just 4 light-years away around a small, faint red star, then it may be far more common than we ever imagined. Perhaps life is not the exception in the universe but the rule. The implications are staggering. Scientifically, this confirmation forces a reassessment of many long-held theories. Our models of planetary formation, climate stability, and biological emergence will need to be re-examined. Missions that were once solely about mapping stars and analyzing rocks will now also be charged with searching for the building blocks of life. Future observatories will likely be designed with this goal in mind. New technologies, from direct imaging telescopes to interstellar probes, may be fast-tracked. The study of astrobiology will likely surge in prominence, blending disciplines such as chemistry, planetary science, and evolutionary biology to address the emerging reality that life may be all around us, waiting to be found. The James Webb Space Telescope will continue to play a central role in this unfolding story. Its mission is far from over. Scientists plan to observe hundreds more exoplanets in the coming years. Some of these worlds may resemble Earth. Others may challenge our definition of what a habitable planet even is. Each observation adds a new piece to the puzzle of how life begins and survives. In addition to studying exoplanets, Webb is also revealing the distant past. Its sensitivity allows it to capture light from galaxies that formed over 13 billion years ago, giving us a glimpse into the early universe. By observing the birthplaces of stars and planets, Webb helps us understand how complex systems like solar systems come into being, systems that, perhaps more often than we thought, include life. And yet, beyond the scientific ramifications lies a more human truth. The realization that we are not alone expands our sense of belonging in the universe. It connects us not only to distant planets but to a broader cosmic story. It challenges us to think beyond borders and species, beyond time and space, and to consider that life, fragile, determined, and diverse, might be a fundamental trait of the cosmos itself. As we continue our journey into the stars, the discovery of life on Proxima B will be remembered as a pivotal moment, a moment when science crossed the threshold into something greater. It is a call to explore, to learn, and to connect with a universe that is now, more than ever, alive with possibilities. Here at Waves Discovery, we are committed to bringing you the most extraordinary and thought-provoking revelations from space. As the James Webb Space Telescope continues its mission, we'll be here to explore its discoveries with you. From ancient galaxies to new worlds, from cosmic dust to alien life, the universe is finally speaking. And for the first time, we're beginning to understand what it's saying. Don't forget to like, share, and subscribe if you want to stay updated on the most incredible findings beyond our world. This is just the beginning. As we enter this new chapter of space exploration, one thing is clear: the cosmos is no longer silent. It is speaking, and life is answering back.